Hello, Big Reds. This is part two. All right, we need graph paper for this one, for the review video. So you can take your time and graph this stuff and write it down. That's great. All right, this is a big part of the test. A lot of points from this part. So first of all, we'll start with this this rectangle right here. Very important. Okay, so I'm going to zoom up on the rectangle, and it says first of all we want to find DE. Well, DE is just the distance between points D and E. Now notice that it's on a slant, so I can either use distance formula or Pythagorean theorem. I'm going to use Pythagorean theorem. So if I go up and I go over, I'm going up 1, 2, 3, and I'm going over 1. So I'm going to take 3 squared plus 1 squared equals c squared. Doing my Pythagorean theorem, right? 3 squared is 9. 1 squared is 1. So I add these together, I get 10 equals c squared. I take the square root. And let's see, what is the square root of 10? It's about 3.2. So the length of side DE is 3.2. Now I could do the same thing from G to F, and you can see that it's 3 and 1 as well. So F to G is also going to be 3.2. All right, now let's look at E to F. E to F, that's what we want to find next, E to F. So I go across on the line and go down. I could go over 1, 2, 3, 4, 5, 6, go up 2. So I take 6 squared plus 2 squared equals c squared. When I do that, I'm going to get 36 plus 4 equals c squared. The square root, I get 40 here, equals c squared. Take the square root and figure out the square root of 40 is going to give me about approximately 6.3. So that means that EF is 6.3, and DG, if you notice, it's also going to be 6.3 units. All right. Next, it's going to have us find D to F. This is where students seem to struggle a little bit for some reason. I'm not sure why, but from D to F, that's this diagonal right here. So I'm going to draw that in. D to F. You know what? I'm going to use a different color. Just maybe you can see it better. We'll see. D to F. All right. And if I want to find the lengths from D to F, I make my own little triangle right on the line here, straight over. My colored pencil isn't very sharp here. So I'm going to count over. I go 1, 2, 3, 4, 5 squared plus 1, 2, 3, 4, 5 squared equals c squared. All right. So this is going to be 25 plus 25 equals c squared, or 50 is equal to c squared. Take the square root. Let's see, what is the square root of 50? About 7.1. So this is going to be 7.1. All right, now I'm going to try to do, I want to find E to G. I'm going to do that in a different color, just so you can see it better. If you want to use different colors on when you do this on the test, you are welcome to do that. It helps you, because there's a lot of stuff going on here. All right. From E to G, I'm going to go over and then up. You can see I'm going over quite a bit and only up a little bit. I'm going over 1, 2, 3, 4, 5, 6, 7, and going up 1. So this is going to be 7 squared plus 1 squared equals c squared. Now, it says 7 squared is 49, 1 squared is 1. What do you know? This is still 50 equals c squared, square root. So this is still 7.1. How about that? They have the same length diagonals. Kind of cool, huh? All right. Now we want to figure out the slope of DF. Well, the slope of DF, you can see DF, it went down 5 over 5. Okay, so that means it's going to be a negative 5 over 5, which gives us a negative 1 if I reduce it, right? The slope of EG, it's going up 1 over 7, so its slope is 1 over 7. All right. Now, to find the area, we have to multiply length times width. So I'm going to go back up to my lengths of my sides. I'm going to multiply these two by each other. 3.2 times 6.3. So I'm going to take 3.2 times 6.3, and that's an approximation, so I put approximately. 3.2 times 6.3, and that's going to give me about 20.2 square units. That's for my area. Now perimeter, I add up all the sides, so I have 3.2 plus 3.2 plus 6.3 plus 6.3. And again, that's going to be approximately. Let's see what that is. Do it on my calculator as we speak. 19. That is my perimeter. Okay. Now, we have some very important questions up here that are word questions. So let's look carefully at this one. It says, what measurements show DEFG is a parallelogram? Explain. Well, one thing I could do to see if it's a parallelogram, I know that opposite sides in a parallelogram are congruent. Well, if you look here, down here, if I look at DE and FG, they're congruent. They're both 3.2, right? And I have EF and DG are the same. So that shows me that it's a parallelogram because the opposite sides are congruent. So I can say something like two sides are 3.2 and two sides are 6.3 units. That'll work. Now it says, what measurements show DEFG is not a square rhombus? I think the same thing is up here. You see, if it's a square, all the sides are congruent. You can see clearly these sides are not congruent, so it cannot be a square rhombus. So you could say the same type of thing, answer for these first two questions. All right, finally, we know that opposite sides are congruent, but one thing I could do is I want to figure out what makes this a rectangle. Well, I know the opposite sides are congruent, make it a parallelogram, but to make it a rectangle, I would have to figure out the slopes of the sides. Slopes of the sides should be opposite reciprocals of each other to be a right angle. So here, if I figure out the slope of D to G, it goes down 2 to the right 6. So it's negative 2 over 6, which reduces to negative 1 over 3. Now if I find the slope of FG, that's going up 3 over 1. So the slope is here is 1 over 3. I'm sorry. That's a donut point. Catch Mr. Fischel. Tell him to give you a donut point for that one. Up 3 over 1 is 3 over 1, right? Now notice that these are opposite reciprocals. This is a negative. This is a positive. And you see the numerator and denominator have switched. That makes this a right angle. So if we have right angles, that's what makes this a rectangle. Okay, good. This is the end of part 2. We have one more part to go. You can do it, Big Reds. You can do it.